Now, in order to do the next problem, we have to recap. When graphing, you have 4 quadrants. 1, 2, 3, and 4. Quadrant 1, you have 0 through 90 degrees, 90 through 180, 180 through 270, and then finally 270 through 360. Now keep in mind, you have positive x, positive y, negative x, positive y, negative x, negative y, and finally positive x, negative y. Now let's refer to the question. You're given 4 different vectors with different degrees and magnitudes. So first let's go with A. A is at 170 degrees. This belongs to quadrant 2. Recall to the graphs. 170 degrees is in the area in the range of quadrant 2. Now, we will draw quadrant 2's graph. You have a magnitude of the vector to be 5 meters. And your degrees in total is 170 degrees. Now let's go for B. B is 25 degrees. It is located in quadrant 1. So we'll draw quadrant 1. You have your vector. Magnitude 25 degrees. I'm sorry, degrees, 25 degrees. Magnitude 15 meters. Now let's go for C. You have 120 degrees. This pertains to quadrant 2. So we're going to draw quadrant 2. Vector. Measured to be 120 degrees. Magnitude 10 meters. Now let's go for the D. D is at 330 degrees. This refers to quadrant 4. Draw quadrant 4. Draw your vector. You have a total of 330 degrees with a magnitude of 5 meters. Now we're going to be adding all the following vectors, solve for magnitude and angle. So first, let's work with A. This example will take a while. AX, AY, 5 meters for the magnitude, cosine of 170, sine of 170 as well. Calculate 170 cosine times 5 meters. You have a negative 4.9. Now let's go for AY, 170 sine times 5 meters. You have positive 0.9. And of course, both of these are meters. Now let's go for B. BX, BY. Magnitude 15 meters. Cosine of 25. Sine of 25. Refer back to the calculator. 25 cosine times 15 meters. 13.6 meters. 25 sine times 15 meters. 6.3 meters. Now let's go for C. CX, CY. 10 meters. Cosine 120. Sine 120. Run through the calculator. 120 cosine times 10. Negative 5 meters. Then 120 sine times 10 meters. We'll call it 8.7 meters. And finally, D. DX, DY. Five meters. Cosine 330. Sine 330. Run through the calculator. 4.3 meters. Let's go for DY. Times 5 meters. Negative 2.5 meters. Now let's refer to something else. Switch colors. Okay. Quadrant 1. Your x is negative. Your y is positive. You got the same factor here presented in your x and your y. Quadrant 2. You have positive x, positive y. You notice that the same here as well. Quadrant 2. Negative x, positive y. Noticed as well. And then finally, quadrant 4, positive x, negative y, noticed as well. So now we're going to add all the x's and all of our y's. So draw a little division here. AX, BX, CX, DX, negative 4.9 meters, $13.6 meters, negative 5 meters, and finally 4.3 meters. You add all these together to find sum x. -4.9 negative plus 13.6 minus 5 plus 4.3. 8 meters. Now let's do the y's. AY, BY, CY, DY, sum of y's. We have 0.9 meters, 6.3 meters, 8.7 meters, negative 2.5 meters. Add them all together. 0.9, 6.3, 8.7, and then 2.5 negative. 13.4 meters. So let's group them. The sum of x is 8 meters. Sum of y, 13.4 meters. I have a positive x. I have a positive y. Most likely, I will be in quadrant 1. First thing, let's solve for the angle. Inverse tangent of sum of y divided by the sum of x. In this case, 13.4 divided by 8. (13.4) divided by 8, inverse tangent, 59.2 degrees. That also matches quadrant 1. Then finally, let's find the resultant magnitude. Let's use another color. Sum of x squared, sum of y squared. Now, 8 squared, 13.4 squared. Now Let's do this separately. 8 squared, 64. 13.4 squared, 179.56. Add them together. 243.56. Square root this. 15.6 meters. These represent your answers. The magnitude of the added vectors and its corresponding angles.